Hi, and welcome to AWS Public Sector Summit, Operationalizing Microsoft Workloads. My name is Mike Colson. I'm the Solutions Architect Manager for Army, Air Force, and Combatant Commands with the DoD team. And with me today is...
My name is Jason Updike. I'm a Senior Solutions Architect on the Department of Defense team at Amazon Web Services.
And so we're going to talk about how organizations look at Windows operations and how they manage those workloads within the AWS platform. And so, as all things AWS, we operate through the flywheel process. And so we're going to talk through how we do infrastructure provisioning, how we move from that into configuration management, the capabilities around monitoring and performance, how we automate the process for governance and compliance, and then how we get into resource optimization. And really, when we're talking about this, we're talking about how we automate the process, how we go through and eliminate the hands-on keyboard aspect that really drives those security vulnerabilities within our organizations, because the worst person within your org is actually the people, right? The people make things less secure. And so what kind of engineers are we trying to hire? Lazy ones. And we want lazy engineers because lazy engineers are never going to do the same manual task over and over again. The more they automate, the better we are, the better they are, the better our organization is, and the less bobs we get in the org that are going to go out and fight security by having something that comes out of compliance. And so the way that we automate the provisioning of resources within AWS is, of course, through CloudFormation. And so we can take entire Microsoft workloads, deploy them via a CloudFormation stack, and eliminate the human error by getting to a point where we have repeatability and eliminate that time consumption that it takes to stand up an environment. Quick show of hands, how many of you had to stand up a SharePoint environment in your career? That takes months, if not years, right? I mean, that's a serious undertaking, and that's not full provisioning, but all of the configuration that's underlying. What if we automated that process and made it easier? And so through CloudFormation, we have the ability to create or use existing templates, save them locally, or leverage S3 as a storage point. We can create stack sets of these CloudFormation templates, create those into specific stacked resources so that we can maintain them and make them segmented. So different parts of our installation or deployment process are done in a seamless fashion, but in a repeatable fashion that we can go in and edit one piece without affecting the overall architecture. So think very microservices, but the way that we deploy our Windows architectures. And so AWS has already taken some of this on and developed Quick Starts, and we use our SA teams as well as our ProServe teams to get engaged. So things like deploying Active Directory servers or link servers or RDP gateways or SharePoint, they're already configured for you, and all you have to do is launch the base template or go in and edit the base template to configure it for your specific environment. And so with this in mind, right, this is the initial part. This is how we launch that infrastructure, but then we need to continuously automate and manage the environment as from an operational perspective moving forward. And so now we're going to go from, how do we deploy this, which is very simple. We just click the button and boom, we have the environment, to how do we maintain that operations and control. So I'm going to turn it over to Jason and talk a little bit about configuration management.
Yeah, thank you, Mike. So we talked about the infrastructure provisioning, and we talked about that might happen through CloudFormation. That might be that you've migrated an application from on-premises into the cloud. Perhaps you can keep in mind that three-tier application that Mike showed today as we continue to go through this flywheel of effect. So like I said, we've handled the provisioning piece, but now you've got to manage and do configuration management on your fleet of instances and on your cloud applications while they're running in the cloud. That might be, with the Windows workloads, that might be SQL Server, .NET, IIS, those sorts of things that you need to deal with and work on. So all the traditional tools that a Windows administrator traditionally used on premises are still available for you to use in the cloud. That includes things like RDP, remote PowerShell, the snap-ins with the MMCs, we're all familiar with those in the Microsoft world. You might have third-party management tools. You can still continue to use all those in the AWS cloud. There are security considerations that we'll talk about with using those. But even with all that, some customers have asked for a more cloud-friendly, cloud-native approach to help lift some of that administrative burden off of them as they're managing their Microsoft workloads on the AWS cloud. So we've created a solution called AWS Systems Manager. It's been out for a while. AWS Systems Manager has a plethora of capabilities. Unfortunately, we can't talk about all of them today, but we'll certainly talk about two that are very critical to managing your Windows and Microsoft workloads in the AWS cloud, including AWS Systems Manager Run command, as well as AWS Systems Manager Session Manager. These allow you to do things like reset local admin passwords, do bulk administrative tasks across your EC2 fleet of instances, update group policy, configure backups, all the stuff that's critical to running your Microsoft workloads in the cloud. So with Systems Manager Run Command, we're going to do a demo of both of these shortly here. But Run Command is really great for that bulk set of activities that you want to run across an entire fleet, maybe 10, 100, 1,000 servers, and you want to do those commands non-interactively. So it's great for bulk actions. For interactive, we've got a solution called AWS Systems Manager Session Manager, which enables you to get an interactive console session to your particular instance. Maybe you want to do troubleshooting, maybe you want to reset services, maybe you want to gather further logs, see what ports are open in the operating system, that sort of thing. So here's a diagram of what this kind of looks like. On the right-hand side there, you see we have a VPC with a private subnet. Imagine that 3-tier application that Mike showed is running in there, and you need to configure it and manage it and all that kind of stuff. The great thing about AWS Systems Manager in this case is that you can audit and keep logs of everything that's happening across these two capabilities that I'm talking about, Systems Manager Run Command as well as Systems Manager Session Manager. You can log this stuff to an S3 bucket, Cloudwatch, as well as send out SNS topics to alert folks when things were run and whatnot. The great thing here is it's a cloud-native capability, so I'm going to show you that when I use these tools, I have actually 0 ports and protocols open on my security groups for these particular instances. So when you think about the cost savings of not having to have bastion hosts, NAT gateways, other third-party tools, and then the security involved in managing and keeping those things up to date, et cetera. So let's go ahead and dive right into a demo here. If the crew can switch that over to my laptop, please. So here I am on the AWS Systems Manager homepage. You can get to that by coming into Services. It is underneath the Management and Governance section, Systems Manager. Like I said before, there are a lot of different things that Systems Manager can do. Mike will show some more of it later. But in this particular demo, I've got we're going to assume that I want to reset the local admin password across a large number of instances, 10, 100, 1,000 instances, in my case 3 for our demo. I've actually got that local administrative password stored in my parameter store here, but we're going to focus on Run Command. So like I said, Run Command is for that bulk activity of actions across a fleet of instances. You can see here that I can view the command history. And basically what I do is I choose what we call a command document. And command document simply tells Systems Manager what type of task you want to perform against these particular set of instances. Obviously you choose the target where you want to run that command document against. And those commands, we're going to do a remote PowerShell shortly. And then you can also do that based on tagging or resource groups that are built into the AWS cloud. So you can see here, I ran one earlier called AWS Find Windows Updates. Let's just go and look at the output of that. I ran this across all 3 of my instances. We can view the output. And you can see here, this particular run document or command document says, hey, go look for all the available patches for that particular operating system, looks at its current state, checks Windows Update, patch now, all that kind of good stuff, and shows you that I've got one critical update and one unspecified important update here. But let's go ahead and run a command, a new one. So what we'll choose is, by the way, you've got all different kinds of stuff here. You can configure Docker, install an application. Each one of these has different parameters that you would input it. So for installing an application, that might be an MSI or the source directory of the application install files. And we're going to run a remote PowerShell. And what we'll do here is I've got a little bit of PowerShell code written here. It's basically taking net user and changing the local admin password across these instances to that parameter that I have stored in parameter store, and then echoing out that it was successfully done. You've got options in this to set execution timeouts. You can choose manual instances. Like I said, I've got 3 instances here. One's a 2012, I've got a 2016 and a 2019 Windows operating system instances here. You can see the version of the agent, the SSM agent. I have things like rate control. If I'm running this across a large number of instances, I can kind of control the flow and how often I want to run this. I can do rolling commands across my fleet with rate control. I can enable writing to an S3 bucket. I'll disable that for this particular one. I can send SNS. The cool thing is I can also access Run Command through the console like I'm showing you here, but also the AWS command line interface or the AWS SDK, as well as the AWS PowerShell tools And it even gives you the command that you would run on the CLI there. So let's go ahead and run that. I must have only clicked the 2. And, oh, there's 3. And you can see successful. Let's just look at the output on one of these. You can see, and I'll be changing that admin password before the session's over. So next we need to talk about Session Manager. So we talked about run command because it's good for bulk actions across a fleet of instances. Session Manager, I want to get interactive with the box. I want to troubleshoot it. I want to look at logs. I want to maybe look at the OS firewall rules or the IIS logs and look at open ports, that kind of thing. So the great thing about Session Manager is I can just come in here, click Start Session. I can choose with one click which instance I want to start a session with, and I get a web-based console session. Hopefully. Let's try a different one. There we go, and I can interact with that thing. Maybe I want to look at the open ports and protocols and the process IDs that are listening. I can interact with this machine through a browser. Now, the really great thing about this particular capability, both of these actually, is I want to just quickly show you that all 3 of these instances are using this Launch Wizard 1 security group. A security group controls the ingress, egress from a ports and protocols perspective to my instances. It's kind of my instance level firewall, if you will. If I look at that and I have absolutely 0 inbound rules. So no RDP, no SSH ports, no anything opening. All this capability is happening natively with Systems Manager through the cloud. And that can have a great effect on the cost and the management overhead to manage those remote access, remote configuration capabilities. So that's good. Over to you, Mike. Right. Back to the deck, please.
Great, thanks, Jason. There, perfect. So, as we talked about, okay, good. So as we talked about the process for doing those bulk management, another thing that comes up when we're doing any sort of Windows management or automation and orchestration within any environment is patching, right? I mean, let's be honest, we have to do it at least once a month. So when we're looking at patch management, we want to have a way to manage the instance, manage the way that we're pushing the patches, have centralized repository for that. And SSM is allowing us to have that managed patch repository as well as a managed patching service. And so in addition to being able to maintain SUS and manual updates, we can also do third-party updates through the Systems Manager console, and we can manage the actual AMI that we're using as the base. So we can update patches through Patch Manager, and we can set maintenance windows. We can update the instances within our environment, but we can also manage the AMI that we're using to deploy those images. And so Systems Manager or Patch Manager is allowing us to scan instances for missing patches, so to display those vulnerabilities and give us reports. We can apply missing patches in an individual or bulk manner. We have the ability to create baselines so that we can assure that we're not creating drift. And then we can have that maintenance window where we can create recurring schedules and automate the process for patch maintenance, and integrating these with things like run command and Lambda step functions and additional automation tools, so that as we're going to deploy a new service or a new environment, we're taking that baseline and applying it to that environment as it's rolling out. And then one of the things that becomes a challenge, particularly when we're talking about public sector and commercial, is we like to have this concept of hardened environments and hardened images. And so we create that baseline image, and then we have to apply that image across our architecture. And how do we maintain baseline? Because that image is going to eventually create drift because an AMI is not constantly powered on. So we have the ability through the automation tool to launch the instance, update the components necessary, update the patches, create things like run things like sysprep, update additional applications within the stack, manage what KBs are actually being installed, manage what applications or third parties are being updated, and then we create a new AMI of that baseline, and now we update the AMI that we're using within our deployment stack. And all of this is done through Systems Manager automation. And so we're actually going to get into a demo where we actually show you the simple common tasks of how we walk through this, how that workflow is done, and some of the documents that Jason showed you are just basic JSON documents that create the process by which the scripts run, and then how this ties into run command. So we'll jump over to the demo here. And so again, we're starting off in AWS Systems Manager. We're going to go into automation here. And so I actually have a couple of these in process. We're going to kick off a new automation process. Do AWS update. Got to type things right. AWS Windows, there it is. Man, I'm having a fun day here. AWS. And we're going to select Update Windows AMI. And so we're going to leave default runtime version, click into here, and here's where we get to input our parameters. So if we look into EC2, we're going to look at our AMIs. We have this old Windows AMI that is the current baseline for our environment. So we just copy the AMI ID. That's going to go into the source AMI ID here. We're going to select the assumed role. In this case, we have an EC2 SSM role. That's going to be the assumed role. And you can create a separate instance profile name. In this environment, I actually maintained the same profile name for both. So it's just EC2 SSM. And then it's going to create a target name. And so this is going to be the updated AMI name for the instance, for the AMI when it's stored in your AMI repository. And we're going to go with the micro because we want the smallest instance type possible, and that's what we built this off of. And we can optionally set the subnet ID, the included or excluded knowledge base articles or patches that we want to have. We can categorize what this is being used for, what the AMI is most likely for, set security levels. We can look at restrictions on how old or how new those patches are so that we can restrict what time frame we want to apply patches from. So say if we're in a compliance regime where we don't apply the latest and greatest patches until they run through some QA cycle, we can actually apply that here. And then we can run pre or post update scripts. So if we need to patch additional third-party products, or if we know a KB is gonna break a third-party solution and then we have to do a reinstall or do some tweak to a key, we can do that on the back end. And then we also have the ability to look at that CLI command, similar to how Jason was showing before. And so we're going to go ahead and execute this. And so this takes a little while to kick out. So we'll actually look at a completed one. But when we look in the execution state, this will show pending. And these are all of the executed steps. There's 14 steps that this goes through, where it launches the instance. It checks that the OS is compatible with what we're patching. It runs the pre-update script. It goes through, checks baseline within config, validates and updates the SSM agent, updates any driver requirements, and then goes into the updates of the install script, and then runs any post-update script. And then after that, we look at page 2 here. Then it runs sysprep, stops the instance, creates the image, and terminates the instance that was created for the patch. So if we actually look in EC2, we will see a initialized EC2 instance, and this is spawned off that AMI, and it's going to run through those stages that we saw. And then what will happen is it'll actually kick out an AMI and append the name and date and time when that AMI was created. So if we look at let's go back and look at a completed one. So we look at a successful implementation. 14 steps were executed. Here's the execution description, the document version that was done, and again, this is all that JSON documents that we're using to do the update script. And then what the output was. This is the new AMI name base that's registered within our AMI repository. So that, in a nutshell, is how we update our base AMIs, and this allows us to then move to the creation of additional environments based off of that AMI. And we're good to shift back to our presentation. Awesome. And back to you, Jason.
Great. Thanks, Mike. So that was patching and keeping your images up to date. The next topic is, I'm sure one many of you can attest to, the ability to keep your most important applications, your critical applications up and running, and the performance of them operating as highly as possible so that your customers have the best experience possible. So to achieve this, you need visibility into your applications and how your applications are using, which resources, how those resources are performing. And many of these applications are very complex. They have many different individual pieces that you have to look at, and it can be a daunting task to have visibility across the entire stack of application resources. And that can be hard to kind of control and look at IIS logs and SQL and application logs and performance counters and all that kind of stuff. You may have heard of Cloudwatch. Cloudwatch is an AWS provided service. It's fully managed for management and monitoring of your cloud workloads. It allows you to do this across your AWS resources, hybrid cloud resources, as well as on-premises workloads. And basically gives you visibility into how your applications are performing on top of AWS. You can get these performance counters and things for over 70 different AWS services, as well as OS performance logs, application logs, that kind of stuff, a unified view with the Cloudwatch unified agent. It allows you to create high resolution alarms against those particular metrics and to create custom dashboards that allow you to see across a wide variety of resources in one quick view, customized to your preferences and your needs. So using Cloudwatch, this also gives you, bias for action here. AWS is strong, and it basically gives you the needed information to give you the level of detail you need to get things done and make sure that your application is operating to the highest standards for your customers. So even with Cloudwatch and all the things that you can do, our customers have given us feedback that it's been hard to get a full grasp on observability for .NET and SQL workloads running in AWS. Those challenges can include things like figuring out which thresholds that your alarm should be set to, which metrics should you be looking at across a complex application like a .NET or a SQL Server 3-tier application. How can you get better visibility into troubleshooting these problems and that kind of thing? So because of that customer feedback, 95% of the features and products we make at AWS are based upon customer feedback. Because of that, we created Amazon Cloudwatch Application Insights for .NET and SQL Server, which enables you to automatically, using machine learning, to build these automated dashboards, as well as automated triggers and thresholds for your alarms based upon the system running in its past. So it's always creating those automatically for you and helping you to have that most relevant information to you. And I'll show you in the demo how you can start to give the system feedback and help. Was this alert helpful for you? You can inform the system whether or not that particular alert is helping you or not. It enables you to view this stuff easily on a simply to use dashboard, and hopefully will help your applications run more smoothly so your customers can have a better experience. So some examples of the things that Cloudwatch Insights for .NET and SQL Server can provide are things like SQL Server errors, failed backups, scheduler deadlocks. You might see memory pressure in your .NET applications. You might have load balancer latencies, might be high CPU, those types of things. We're also going to look at specific SQL logs in our particular demo. And in the past, before Cloudwatch Application Insights for .NET and SQL Server, you would have to be individually looking at all of these different types of log files as examples. You'd have to be doing manual correlation and manual data mining to try to figure out exactly where your application might be struggling. So let's go ahead and switch to the demo. And let's switch to the demo screen, please, the laptop. And we're going to start on the Cloudwatch Application Insights for .NET and SQL Server. I will tell you that this capability is in limited preview right now. We'll show you a link that you can request access for your account for this technology. I did talk to the product managers recently. They said it's going to GA, general availability, very soon. So if we look at Cloudwatch Application Insights for .NET and SQL Server, you can start by getting started here. And I'll show you quickly how you would go about onboarding one of your applications, your N-tier applications. And let's just look at this HR web application. I can choose it and go to Configure Application Insights. Basically what you do is you can tell the system which tier these particular instances are in your application. So this is our IIS tier, and we'll just keep it simple for now. You get the idea here. I picked the wrong one. Let's pick a different one. Let's go here. maybe. Must be this one. Well, basically you onboard the application through this. You can either choose if it's an IIS web front end, you can choose if it's a SQL server or whatnot. And what happens is it basically tells the Cloudwatch agent to automatically deploy things like how to pull the SQL Server logs because that particular one is a SQL Server, how to pull the IIS logs because that particular one is an IIS server. So it automatically sends the configuration of the Cloudwatch agent on the instances to collect this information and send it back to Cloudwatch Application Insights. So let's go back to the one that I already have configured. I want to show you the problem that I'm currently experiencing. This is my most important application. It's basically AdventureWorks. We're just doing a simple .NET application here. But my users have called me and told me that I'm having trouble editing fields. I get a very descriptive error that's obviously easy to troubleshoot. I know exactly what the problem is, right? No, not really. This might be a front-end problem. This might be a load balancer problem. This might be a high CPU resource bottleneck problem. I really don't know unless I go dig into all those logs or I have AWS Cloudwatch Application Insights. So let's go to our dashboard. And we've got this application already configured and onboarded. You can see here I get a dashboard that was automatically created for me. This was all done by the service itself. You can see that we're doing things like CPU utilization. There's been some thresholds set by the system. The red is the thresholds the system set. The blue is the thresholds that I'm currently running at. But I also start to get different problems in detection. I get kind of like some things bubbling up to me that might be an issue. And I'm seeing a lot of these high alerts on SQL transaction log being full. Well, look from that error, I really wouldn't know that would be a transaction log full issue. But Application Insights has, since it's monitoring all the tiers of my application, has been able to detect that based upon the SQL log. So let's look at one of those. You can see here that SQL Server issues a 9002 error when the transaction log is full. It gives you some advice here. You can also see the actual logs raw file itself, so you can confirm that yes, indeed, that is what we're seeing on that particular instance. But let's go one level deeper because we want to solve this so our users aren't having any more issues. Let's actually go look at the database. So I'm actually on the database using SQL Server Management Studio here, and I can execute a command that shows me the log file size for our particular application. Our AdventureWorks database, as you can see, the log is completely full. So we do indeed have a problem here with the application log being full. Application Insights was able to let us know that. So what we're going to go ahead and do is by doing a backup, we can clear that log. So we'll run this particular SQL. The backlog was clean. We'll check the log file size again. And you can see we're now down to 11% space used. So I think we've resolved the problem. But let's go back to our application and refresh it. And try our edit. It might take a second for it to work here. Let's do a quick refresh. And sure enough, our application is back up and running. It takes my edit now that we've cleared the transaction log, and all is well. Our users are happy again. Cloudwatch Application Insights for .NET and SQL Server helped us identify that issue, even when we had a really benign error message like an error occurred, right? I believe that is it. Let's go ahead and switch back to the deck because I do want to quickly show you the QR code you can use to get access to the preview. If you want to take a picture of that, you can get access to that particular preview. Like I said, it is going to become generally available very soon here. Back over to Mike.
Yeah, we'll leave this up for a second so that you can get your snaps in. This is the only time I'm like, yeah, take a picture of the slide. All right, so we've talked about how we do the patching, how we do the management, how we do some of the performance reporting and monitoring and management. We're actually going to get into everyone's favorite topic, and that's compliance and governance, right? Who doesn't love a good compliance conversation? Whoop, whoop. All right. So getting into compliance and governance, one of the things that we need to maintain is our inventory. We need to know what we have, how we manage it, what level everything's at, what the patch level, what the OS level is, what software is installed, how applications are configured, what licenses are being maintained and managed, what files are out there, network config, registry config, all the fun stuff that we all get excited about and wake up in the morning as system admins, right? The great thing about when we get into a cloud environment and AWS has these tools with SSM is that we have inventory control and greater insight into what our workloads look like directly through SSM. So through SSM inventory, we are able to run the SSM agent on all AWS provided AMIs. So it's there by default. And all we have to do is create the roles and the processes that allow us to set those roles to the instances as they are created or after they're created, and the inventory will start rolling immediately. And we can pull that inventory in, check and manage the config, get reports, and I'll show you what that looks like here in the demo. AWS Systems Manager Inventory allows for the inventory and collection of all of this data. It provides useful dashboards and reports, and so that we can then have a solid configuration and governance strategy. With a Systems Manager, not only are we collecting that data and all of the information about the instances and the software that's installed on the instances, but it also allows you to enable application and asset tracking. And so think of things like application license management that we're doing across organizations, or OS license management we're doing across organizations. And this doesn't just apply to Windows, right? Systems Manager works with Linux as well. And we have the ability to stand up Yum servers and do Yum patch management just alongside of our Windows patch management. So we're able to use Systems Manager for all of these resource types. And so when we're talking about going from governance into compliance, one of the things that we have to look at again is that configuration drift. So allowing for configuration of things like RDP access, firewall rules, enforcing the application settings, looking at how we manage the activation, right? So sometimes we have that fun issue where Windows box has been unable to access and validate activation, and we have to go back through the activation process. We can actually manage and maintain that through our Systems Manager, System State Console. And we have the ability to look at how we set up and join Active Directory. So if we want to manage that in an automated fashion, or connect or disconnect those instances, or we want to bootstrap instances with specific software, all of this can be done through AWS Systems Manager, State Manager. And so when we think about System State Manager, think about how you would do configuration management, how you would manage policies, and how you would manage EC2 instances, but not just EC2 instances, because we can also create groups and pools of resources and install the agent to on-prem resources. So now we've centralized the patch management as well as the configuration management of resources running both in the cloud as well as on premises. And so now we have the single pane type solution of patch management, configuration and baseline management, and deployment for both on-prem and in the cloud. So we're going to switch over to the demo here, and I'm going to show you, I have a RDP desktop set up, and in my console, we're going to switch over to Systems Manager. I'm going to start off by showing you inventory. And so the inventory dashboard shows you what's in the inventory, what's been enabled, what's covered within this configuration and dashboard, what applications are installed. This is a very vanilla installation, what those server roles look like, OS versions within my environment, and then the top 5 services that are being used by those resources. And then actually shows you the managed resource name, the agent version that's installed, and the IP address of those instances. When we go into State Manager, oh, and I would be remiss if I didn't say this for Public Sector Summit. I'm doing my demo in GovWest. So little mic drop, boom, look at that, it's in GovCloud. All right, so when we're going through what this looks like, right, we're gonna actually create an association. So for this, let's say Bob was acting up again, and Bob decided that he's gonna create an instance and allow RDP to run wild and run amok, but we have a vulnerability in our organization. Maybe there was some sort of drift. We want to deny RDP for particularly this instance that Bob's really excited about, because Bob turned it into a Minecraft server and is managing it in our network. That never happens, right, within the public sector. We know what's running on all of our servers. Okay, so we're going to go into State Manager. We're going to say, give this thing a name. We'll just say it's deny RDP. And we'll scroll down. And again, we see the same the document sets that we had previously. And we're going to do this via PowerShell, because why not? So we're going to AWS run power, select that PowerShell. And because who wants to actually write PowerShell on stage? Not me. We're going to copy some PowerShell commands here to disable RDP. And real quick, I mean, this is nothing crazy. We're looking at the net firewall rule for remote desktop. We're going to go into the deny TS connection and essentially make a change to the reg entry to disable terminal services. And so going back to Systems Manager, State Manager, we're going to go into the commands. We're going to populate our PowerShell in here. We could set a working directory if we needed to. And then we're going to scroll down and select target. So for this, it's this WinDemo RDP1 that they're using. And now we have some choices. We can set this to run on a schedule, so we can catch any new instance within our environment. We could set it for managed schedule. We could set it for cron jobs. We could do some rate schedule builds if we're doing this across multiple instances. We could do no schedule and just say run this once, and we want to get it going. We're just going to leave it on cron schedule and standard association. We can also set severity. So if we need to raise criticality of this and report this back through the dashboard of anything that meets that session state where RDP is enabled, we could do that as well. And we could also write all of these outputs to S3. We're not going to do that for this because all of these instances are going to be deleted after today anyway. We'll kick that off. We'll see this in pending down here. And then it'll start to run. It'll start looking for the instance that it's being run against, and then start doing the check of that instance to make sure, number one, that the current state that it's in is allowing RDP, and that the actual key that it needs to validate is in place. And then it'll change that key, write the update, and we've lost terminal services connections. Come on, that's a ooh-ah moment. That's pretty slick. All right, so that's it for this demo. Let's jump back to the slides, and we'll turn it back over to Jason to talk through Trusted Advisor.
Yeah.
Can we cut back over to slides, please? Thank you.
Thanks, Mike. I thought the demo was great, and great to be able to remotely control and set policy on your devices and instances in the cloud. So our next topic and final one for today is resource optimization. Some of the things that you definitely want to optimize when you're running your Microsoft workloads in the cloud, as well as any other type of workload, would be cost, right? You want to get the most out of your investment in the cloud. Performance of your applications, how are they performing? Are they meeting all your demands? Are you having resource bottlenecks? Do you need to choose a different instance type? Those types of things. And we want to make sure that your security posture is as strong as it can be. So you want to optimize those and make sure that you're not having any open policies that expose you to risk. You want to be aware of any potential AWS service limits that you're coming up against or that you've already surpassed. Service limits are kind of a soft limit to help prevent overrun in your account and those types of things. As well as you want to be able to optimize the storage in your environment. So our customers we're extremely excited about AWS Trusted Advisor. Trusted Advisor basically gives all customers the ability to do these security checks, as well as alerts on AWS service limits. So when it comes to security, we're looking at things like bucket policies on S3, our object storage. We're looking things on ports and protocols open to the world, on security groups, protecting your instances and letting you know about those types of things. And we're talking about best practices for identity and access management, like having multi-factor authentication enabled on your root accounts for your AWS accounts. And then for customers that have enterprise and business support plans, which we recommend for everybody that's running a production workload in AWS, you get the full advisor trusted advisor stack, including the cost optimization indicators. So maybe you're not using all of the resources that particular instance type has available, and AWS Trusted Advisor might actually advise you to choose a smaller instance type with less RAM or less CPU capabilities or less IOPS, that kind of thing, and actually can cause you to save a lot of money. Maybe it's the reverse. Maybe you're coming up against bottlenecks and you need to up the instance size to give better performance for your application. We're also looking at things like performance and the counters that Cloudwatch are informing on us, and we're doing fault tolerance checks across these applications to ensure that your resiliency of your applications is strong, and we're making advisory comments to you in AWS Trusted Advisor to show you those opportunities to make a more resilient and highly available application. So really encourage you to look at AWS Trusted Advisor. Like I said, everybody has access to the security recommendations. Security is job zero at Amazon, web services, as well as the service limits. And then for everybody with business or enterprise, you get the full Trusted Advisor stack. So we've kind of completed our flywheel here. We went through infrastructure provisioning. Mike did a great job talking about CloudFormation templates. We talked about remote configuration management with Systems Manager Run command, as well as Systems Manager Session Manager. That enables you to do bulk activities across your fleet of EC2 instances, as well as interactive connectivity through those. We talked about monitoring and performance, and specifically about application insights into your complex multiple tier applications like .NET and SQL Server applications running. Mike talked about governance and compliance and keeping patching up to date and keeping your AMIs up to date, doing desired state configuration, and managing the security guardrails that you have for your environment, and doing that remotely and in bulk through the command documents that he demonstrated. And then we also talked about resource optimization, in that you need to optimize the Microsoft workloads running in your environment, including cost, performance, fault tolerance, security, and all the like. So hopefully this session has been a great summary of all of the ways that we can help you to operationalize your Microsoft workloads in the AWS cloud. Obviously there's a lot more content and Systems Manager and other capabilities in the AWS cloud to do this, and I encourage you to look at all of the other sessions throughout the Public Sector Summit, as well as online resources. Anything you'd like to add, Mike?
No, I think that was a great summary. And so hopefully, this helps out. This is a very powerful tool. It's something that's going to help you long-term, both from a security perspective as well as automating and being that lazy admin. So be that lazy admin, and thank you and enjoy the rest of the summit.
Thanks, you all.